And our starting point at Macopharma was to measure our carbon footprint. And the methodology considers, in fact, 3 scopes. Scope 1, 2, and scope 3, including not only company's activities, but also its upstream and downstream activities. And this is why 3 of us today are presenting this. The carbon footprint is mainly due to direct purchases, sold products, and energy consumption. So this is basically where we have a role to play, and this is why we are involving raw material suppliers, manufacturers, and governments. Did you know that very recently, a very first study was published in Transfusion, and the authors evaluated the environmental impact of red blood cell transfusion in India. And the authors concluded that the carbon footprint per unit of RBC transfused was 7.56 kilograms of CO2 equivalent. But what is a life cycle assessment? And what is the associated methodology? It is in fact a multi-criteria environmental study that considers all stages of the life cycle. As defined by the European Commission, a set of 16 environmental impact indicators are studied. We recently performed a life cycle assessment of a Macopharma red cells inline filter bag. It is a sterile single-use kit intended for the collection and sampling of a human whole blood unit, preparation and storage of a buffy-cut unit, a plasma unit, and a loco-depleted red cell concentrate unit. Basically, this kit can be divided into 140 different sub-elements, and each of these sub-elements will be analyzed and evaluated in terms of environmental impact. If we now look to the impact repartition by life cycle stages on these environmental indicators, we can clearly see in this figure, as represented in gray, that the manufacturing stage has the biggest impact, followed by the distribution phase in blue, and finally by the end-of-life stage in green. If we now look to the impact repartitions for the manufacturing of the different materials of the kit, we can see also clearly in this figure the prominent role of the PVC raw material, represented in blue, in the impact of the product life cycle. In terms of example production plants, we are working on a new injection process for the breakaway cannula, and we expect a decrease of minus 10% of raw material consumption and minus 70% of scrap. And we are also working on the optimization of the design of the needle guard, and we are expecting minus 50% of raw material consumption and also stain removal. And this action corresponds in fact to a reduction of minus 100 tons of polypropylene per year.
Thank you, Bruno. Good afternoon, all of you. It's a privilege to stand here today to evaluate healthcare. So, what has been achieved? First, look at the production segment. In 2023, we changed with Macopharma the length of the rolls of PVC film to make blood bags from 300 linear meters to 725 linear meters. And this had a big impact, positive impact on the packaging waste. Per linear meter or per kilo of PVC film, the packaging waste was reduced by 34%. It resulted in a significant waste reduction at Macopharma, 4% less waste during the blood bag production, representing approximately 230 tons of CO2 equivalent. And because of the more efficient packaging, we were able to reduce the transports in 2023 up to 14% now in 2024. That's 17 trucks less, saving 19 tons of equivalent CO2. In the future, the near future, we all know that DEHP in blood bags in Europe is disappearing ultimately by 2030. So in this design segment, we are replacing, Macopharma is replacing DHP by DHT. And this has a major impact on the product carbon footprint, because the product carbon footprint of DHT film is about 90% lower than that of the corresponding DHP film. So let's look at the future. What can we do as the joint blood establishments? The first step could be to consider defossilizing the product. How do you defossilize a plastic? You do that by changing from fossil oil to vegetable oil, bio-based oil. Preferably used cooking oil, so you don't compete with agricultural purposes of the land. So why not look at mechanical recycling? Macopharma produces blood bags. Blood bags are not square, they are round, so they have offcuts. These offcuts can easily be introduced in new blood bag film identity. So we can recycle those production offcuts and make new blood bag film out of them. Taking it a step further, looking at recycling of used blood bags. We could collect them, clean them, wash the blood away, scrap them, and make new blood bag film. Technically possible. Another step further is pyrolysis. Pyrolysis of used blood bags. Pyrolysis is a technology where the plastic is heated to 500 degrees Celsius. This creates a kind of oily substances, and of course the 500 degrees Celsius process will eliminate any pathogens or contamination resulting from the blood. And this pyrolysis oil can then be used as feedstock to make monomers, ethylene, for new plastics, new PVC for blood bags. We need a change of mindset. If we want to go circular, things have to change. Now I would like to give the stage to Linda Larsson, representing Karolinska, to show us the view of the blood establishment. Thank you, Linda.
Thank you very much for this kind introduction. Well, a very famous person called Hippocrates said, "First, do no harm." And this is really what we are trying to ensure at the blood establishments. Our first priority is the patients, and we want to make sure that they have the access to safe and high quality blood available for every essential transfusion. However, in the long run, the planet is also our first priority. So the burning question we ask ourselves is that when we choose a blood bag, do we have to choose between the patients or the planet, or is there a way to prioritize both? Every time that there's a tender for a new blood bag, there's a number of regulatory requirements to follow to try to avoid any environmentally harmful substance. And in general, exceptions are only possible if exceptions from this list is only possible if there are literally no other options. So typically DHP has been such an exception, but we soon won't have to think about that anymore. So what is that? Well, we investigated the storage of red cells in a bag that was not only free from plastics from DHP, it was completely free from PVC and from plasticizable. All of them. So it was made of polyolefin, and we used two different additive solutions, PAG-SEM and PAG-TGM, which are both known to be extra good for keeping hemolysis levels at bay. And quite frankly, quality was disastrous. And so why is bad quality blood then bad also for the environment? Well, as you know already, first of all, bad blood can lead to dangerous or inefficient transfusion. If you mistreat red cells, the levels of debris accumulate very quickly in the bag, and you also lose the function, meaning that red cells are unable to deliver oxygen, and also they can't do the work in the circulation. So the countermeasures that we usually take when we see that the values are not great for the blood bag is that we shorten the shelf life. So there are some common grounds here. Both for patient and environmental reasons, we don't want to waste blood. for every lost blood bag, there's an unnecessary impact on the environment. The non-DHP blood bags is another example of this actually, because there were concerns for quality issues when DHP was removed. It's literally the same. If quality drops too much, we might need to shorten the shelf life, and then we risk increased waste. The countermeasures taken to compensate for the DHP loss is that you need to find first a good enough replacement plasticizer, and then simultaneously upgrade the additive solution. I think most companies are going to move from SAGM or whatever they were using and use PAGSEM instead. And Macopharma has shown the combination of the plasticizer DHT and the additive solution PAGSEM offers adequate quality, meaning that very likely there's no immediate risk of having to reduce the shelf life. There are more ways, of course, to reduce the environmental impact. You could look at more joint efforts, which is becoming something that people talk about now during the DHP transition, because not everybody can do all the validation. So it's really been talked a lot about that we need to collaborate, and that's also very good for the environment, because if efforts can be shared and we can avoid unnecessary repetition, then we can save a lot of resources. So back to the initial question, when we choose a blood bag, can we prioritize both the patient and the environment? I would like to say that yes, we can. And the key message from me is that for every wasted bag of blood poses unnecessary impact onto the environment. And blood services should therefore strive to ensure high quality throughout the entire process, all the way from the donor to the patient.